Okay, so we've learned about special right triangles, and I think it's really important that we review them before we start talking about the unit circle. Um, so when I learned about the unit circle, I was given like no information of where it came from. I was just told to memorize this like really aggressive circle with all of these numbers. And I remember sitting there in the front row of my math class, my sophomore year of high school or my junior year of high school, being like, I don't know any of this, I don't understand any of this. And we had a sub that day, so we like really didn't understand anything. But so I kind of want to walk you through it, that way you can see how it's actually like derived or how it's created. And I didn't learn this until I actually did teach it a couple years ago, and I thought this was really cool. So I kind of want to walk everyone through it. So right here I have a 45, 45, 90 triangle. Let me change the color to like a deep red for EMK. Okay, so this is a 45, 45, 90 triangle here. And I know that because these two sides are equal, right? So it's an isosceles triangle, and these two angles are equal. So if this is 90, they all have to add up to 180, so these two must be 45 together. So I'm going to call this X. I'm going to call this X. And then we know that if that is X and that is X, then this is X root 2. And that's the pattern that it always follows. Okay? But what's special about a unit circle is that a unit circle really means a circle with a radius of 1. Okay? So when we talk about a diameter, that's the full length of the circle. When we talk about a radius, it's only from the center out to the side. Okay? So the full, or for the radius of the circle is 1. So if this side right here, the hypotenuse of this triangle, is going to be like our radius in our circle, we're going to call this 1. And so what gets tricky is if this whole thing right here is 1, and in our pattern it's really X times root 2, to get to the side, we always have to divide by root 2. So if we have a 1 here and we want to figure out what this side is here, we have to divide by root 2. Okay, so we have 1 over root 2. And what's important to note is we can't leave it like this, right? So this is irrational. We want to rationalize it. So we are going to multiply the top and the bottom, the numerator and the denominator, by root 2 over 2. Because root 2 over 2 is just the same as multiplying by 1. And if we multiply anything by 1, it just keeps it the same. So this turns into root 2 over the square root of, what's 2 times 2? It's 4. So we have root 2 over root 4. And we know what the square root of 4 is, right? Square root of 4 is just 2. So this becomes root 2 over 2. Okay, so this side right here is root 2 over 2. And if this side's root 2 over 2, then the other side also has to be root 2 over 2, right? Because it's an isosceles triangle. So for a unit circle, this is going to be one of the triangles that we're using, right? And it will come up when we have 45 degrees, because this right here is 45 degrees. Okay. So that's our first triangle, right? That's 45, 45, 90. And we're going to look at our second triangle, which is 30, 60, 90. So this one's a little bit more complicated. When we think about our rule, right, we think about 2x for our hypotenuse, x for our short leg, and then x times root 3 for our long leg, right? And we already know this. We've reviewed this last week or a couple days ago. And so now we want to think about it in context of, okay, if my hypotenuse is the radius of the triangle, right? Or of the circle, sorry, is the radius of the circle. So if the hypotenuse of this triangle is the radius of my unit circle, then this hypotenuse needs to be 1. And so if this is 1, we know that we have to divide by 2, right? I'm going to make that, there we go, to get our short leg. So if this is 1, we have to divide by 2. So 1 divided by 2, we all know what that is. That is 1/2. Right, so the short leg ends up being 1/2. And then to get our long leg, we multiply the short leg by √3. So we figure out that the long leg is √3/2. So we're going to take these triangles and we're going to populate this thing called the unit circle, because this is how it's created. So if I scroll down, let me see if I can do that. It's all going to come with me. Okay, we'll erase this, but I'll write them off to the side so we can see them. See if I can make this bigger. Okay, so let's clear everything. And then off to the side, I'm just going to draw my 45, 45, 90 triangle. Sorry that this looks a little funky, right? So if my hypotenuse was 1, then both of these were √2/2 and √2/2. Right, and this we decided was 45. Okay. And then if I have a 30, 60, 90 triangle, I'm going to draw it like this to start. Right, so right here's 30. My right angle, we know that has to be 60. This is my hypotenuse, so that was 1. Remember, to get to the short side, we divided by 2. So the short side's 1/2. And then to get to the long side, we multiplied the 1/2 by √3. So we ended up with √3/2. So these are the 2 special right triangles that we are going to work with to fill in this unit circle. So if you can see, I'm going to put these in a different color. If the unit circle has a radius of 1, then you know that from here to here, it's got to be 1. So we're going to fill this in as, and we always think about points as x, comma, y. So if this is x, comma, y, it's 1, comma, 0. Because there is no height here, right? We're not going up anywhere. It's right on the x-axis. Okay. And so if that is 1, comma, 0, then over here has to be -1, comma, 0, right? Because this I want you to think of as positive, positive, right? We have positive x's, positive y's. Over here, I want you to think of negative, positive, negative x's, positive y's. Over here is going to be negative, negative, negative x's, negative y's. And over here is going to be positive, negative, because positive x's and negative y's. Okay, so we just filled in 1, comma, 0 because we're 1 unit away and we're 0 units up. And over here, again, we're -1 units away, right? And we are 0 units up. So now we can look at 90 and 270 because those are the other 2 easiest ones to fill in. Okay, so if I'm starting here, I'm going nowhere on the x-axis. So my x is 0, and I'm only going up, positive. So my y is 1. So this ends up being 0, comma, 1. And over here, I'm going nowhere on the x-axis, right? So 0 is going to be my x value. And now I'm going down on the y-axis, so it's going to be comma, -1. Okay. Now I'm going to change the color up and we're going to start to get to the fun stuff. So if this is 30 degrees right here with this triangle, we know how to figure this out. This looks a lot like this triangle right here, okay? So if this is the long side, right, here, we know that that long side has to be root 3 over 2. And if that long side represents x, then we know that this is going to be root 3 over 2, comma. We know our short side has to be 1/2, and our short side's going up and down, which is our y value. So root 3 over 2, comma 1/2. So that's our first section of the unit circle filled in. Okay, I'm going to change the color one more time. We'll make it this nice pink, right? And so now I'm going to look at this 45, 45, 90 triangle. Because if this angle right here is 45 degrees, then that makes a 45, 45, 90 triangle. And so the same thing, if this is my x value right here, because it's a cross, right? It's moving on the x-axis, then this has to be root 2 over 2, right? Because it looks just like this side right there. Well, if that's root 2 over 2, then my y value, right, because this is a 45, 45, 90, has to be the same. So this is going to be root 2 over 2. Okay, well, 60 degrees, we have a 30, 60, 90 triangle. So that triangle should work again for 60 degrees. It's just going to be rotated. Okay, so I'm going to drop this side down. So now I have another 30, 60, 90 triangle, but instead right here is my short side. So if that's my short side, my x is now 1/2, and my y is now root 3 over 2 because that's my long side. Okay, so we've just filled out the first quadrant of the unit circle, and we can keep doing this again and again over here, right? We're just matching those triangles to the different angles and figuring out what side is x and what side is y to match that point. But we could also just think about positives and negatives, right? So if this is positive, positive, this first quadrant, right? And we know that our second quadrant over here is negative, positive, then we can make this and just say, okay, well, this has to be just negative x. It's the same thing, just reflected over. So this just turns into negative 1/2, comma, positive 3 over 2, right? Over here, not much really changes. It's just negative root 2 over 2, comma, positive root 2 over 2. Right? They match up. The only thing that's different is that that x is negative because this part is the negative x-axis. Okay? So then over here, we're going to change this, and this is going to become negative root 3 over 2, comma 1/2. And we're going to do the same thing. Just keep going. So if that's negative root 3 over 2, comma 1/2, then over here, right, they're the same point just flipped over. This is going to be negative root 3 over 2, comma negative 1/2. Right, because both are negative here, x's and y's. Well, this point right here is just going to be negative root 2 over 2, comma negative root 2 over 2. And our last one's got to be negative 1/2, comma negative root 3 over 2. We're going to keep going. Well, this point right here, it's really similar to this point right here. The only thing that's different is that our x's are now positive again. So this turns into 1/2, comma, negative root 3 over 2. Same thing, x is positive over here, right? Because this is the positive part of the x-axis. So this turns into root 2 over 2, comma, negative root 2 over 2. And finally, our last point, again, x is positive, y is negative. So this turns into root 3. You can see that, over 2, comma, negative 1/2. So all, like, these two special triangles really just fill in all of these points. The unit circle is solely based off of these special triangles. Okay, and what is important to note as well is that when we talk about sine and cosine, right, we want to think about, okay, well, if, I'll use this color, if I am interested in the sine of 30 degrees, and I know that sine represents opposite over hypotenuse, right? I care about this triangle right here. So my sine of 30 degrees is going to equal my opposite, so my y value, which is 1/2, over my hypotenuse, which, because this is the unit circle, we know it's the radius of the circle, and the radius of the circle is a unit, which is just 1. So sine of 30 will always equal 1/2. Okay, so even if you type that into your calculator, you'll get 0.5 or 1/2, depending on the setting of your calculator, but it will always equal 1/2. Okay, so if I'm interested in the cosine of 30 degrees, I'm going to take this triangle again, but this time I only care about the adjacent, which is the side next to, so it's this little orange side, the angle of 30 degrees, and the hypotenuse. So for cosine, right, we know that cosine equals adjacent over hypotenuse. So my cosine of 30 degrees equals root 3 over 2 divided by the hypotenuse, which is just 1 because it's a unit circle. So cosine of 30 will always equal root 3 over 2, always. And you might get a decimal, you might get it in this radical fraction form, but it will always equal root 3 over 2. So the end goal that I want you to get from this is how we created the unit circle, okay? And I want us to kind of, you don't have to fully understand this yet, but I want you to kind of start to visualize it, that when we did the cosine and the sine, right, of 30 degrees, we kind of just figured out that sine of 30 was just the y value, and cosine of 30 was just the x value. And that's true for all of these points, right? So I want you to kind of remember down here in this little box that cosine is always just the x value of the unit circle, And sine is always just the y value. So when we talk about these coordinates x comma y, you could also think of them as cosine comma sine, right? Where cosine is always our x value and sine is always our y value.